Hi everyone, this is Purnima Mahalingam and you're watching video lecture series on protection switchgear. Last class we are discussed about the basic working principles of circuit breakers and arc phenomenon and arc extension. Today we continue with that. We are going to discuss about arc extensions, and last class we have seen what is the method of arc extensions and high resistance method. In continue with that, today we are going to discuss about low resistance or current zero method. Come, let's go into the video. Here comes the low resistance method. Here, low resistance method or current zero method. Already we have known that it is application only to AC circuits. Only AC, we know the current becomes zero twice a cycle in case of AC. So in case of AC, we know that current becomes zero twice. Current becomes zero twice in a cycle. When it becomes zero, the arc extensions often longer duration of time. So during the next half cycle, it reappears again if the dielectric strength of air gap is less than the voltage gain between the contactors. Using this property of AC circuit, the arc can be exchanged easily when the current becomes zero. For such conditions, it is privileged the dielectric strength of a medium surrounding the ionizing particle has to be improved. The surrounding the ionized particle is a very, very important thing. So it is possible to either the cooling or sweeping upon the ionizing particles or deionizing the medium. The medium is very, very important. That is what the major thing plays a role plays in the circuit breaker arc extension method. Okay. Now here we have so many different methods. What are the methods? We have arc extension. We have an increasing the length method. What are the methods? Sorry. Increasing the length of an air gap. Here we have increasing the length of air gap. The dielectric strength of the medium can be increased by increasing the dielectric strength. By increasing the arc as in a dielectric strength epsilon is directly proportional to the length. Dielectric strength is directly proportional to the length. Once the dielectric strength medium is increases, then the fault fails and to restrict again, then the flow of the current is interrupted. This arc extinguishes the arc. This is one of the method of increasing the length of the gap. The next one is cooling method. So during cooling, the ionization particles are deionized. The ionizing particles are deionized as a neutrally by means of cooling. Dielectric strength of a medium is increased and the arc is extension. This we know already, we have known. And by high pressure method, when high pressure, if the pressure near the contact is maintained at high value, so the pressure is maintained high, it can be easily extinguished, or can be easily extinguished by rapid deionization method. And next one is blast effect. This next one is blast effect. This type of effect either at high pressure oil is forced to pass through an air gap. So high pressured oil is forced through an air gap, or gas is used uh, in order to sweep away the ionized particles to improve the dielectric strength of a medium. We have four types. One is increasing the length of the gap, and the next one is cooling. Third one is high pressure. Next one is blast. Okay. Now coming here, we can see that in this diagram. We can see when air is flown inside. When air is flown inside, we have an moving contactor and we have a fixed contactor. When the fixed and moving contactor, when it is moving contactor moves, what happens when the air is flowed? What happened? Arc already the arc is produced. When air flows, what happened? This arc flows through the arc splitter. This arc flows through the arc splitter. This is one of the method. By using arc splitter, what happens? We can reduce the percentage of the damage. But by splitting the arc, what happens? The resistivity get increased. The resistivity get automatically increases. What happens? The current flow of electron, the current value automatically get decreases. This indirectly support to the produce of damages to the systems. Okay, so here we have an this is what basic of aspirator. Here, what is an important terms? We have so many terms. What is arc voltage, restriking voltage, recovery voltage? What is an arc voltage? Means the voltage that appears across the contactor of a circuit breaker during the arcing period. When the arcing period, when we have a fixed contactor, we have a fixed contactor, we have a moving contactor. When the arc is produced, at that time, what voltage has happened? That is what arc voltage. And restriking voltage, that is the transient voltage that appear across the contact at near current zero during the arcing period. So during the arcing period, when the near the current is zero, here the near the current is zero. So next is recovery voltage. It is a normal frequency of 50 hertz RMS voltage that appears across the contactors of the circuit breakers after final arc extension. This is approximately equal to the system voltage. This is recovery voltage. This is back to the normal condition. Here we can see the clear picture of this. Here. What is recovery voltage? It is a normal frequency. RMS, the voltage appears across the contactor circuit breaker after final extensions. Here we can the restriking voltage, and again it is recovery voltage. Okay, thank you so much for watching this video. We can continue with this in another day. Thank you so much for watching. Have a nice day.